the transportation industry captures and produces large volumes of data from different streams daily. This can effectively be used to derive insights and help the transportation services provide better customer service and enhance their operational models. With the consolidated and integrated business data, the transportation industry can better manage map routes and track movements, plan and forecast for future endeavors, simulate transportation, manage vehicle diagnostics, minimize fuel costs and delays, and enable fleet management and route optimization. This is Peter. He works as a transportation manager at a private transportation company. The company has an extensive network that spans across various cities and a vast customer base. Peter's routine tasks include overlooking the company's database maintenance for updated data from customer rides. His team is responsible for managing this data, but there have been cases of data mishandling in the past where data was lost due to human errors. Peter is now looking for an effective data integration tool that would help him and his team in streamlining the process and gaining insights from the incoming data to contribute to the overall growth of the company. He comes across Astera Centerprise. After thoroughly analyzing the tool, he is impressed with the user-friendly drag-and-drop interface and extensive functionality of Centerprise. Let's look at how Astera Centerprise can help him integrate data and gain meaningful insights out of it. Peter has customer data in a delimited file source. This data contains information about customer rides. Let's bring this data into Centerprise by using the delimited file source object. For easier computation, many fields in the data such as vendors, rates, and locations are code specific, and Peter needs to update the database with decoded values for these fields. Centerprise has advanced lookup options that Peter can use to generate these values. First, we list values from the vendor field using the list lookup from the list of transformations. Let's map the field vendor ID from the customer data. In the properties of the list lookup object, we'll provide destination values in the column for each source value. Next, we'll list values for the rate codes applied. Let's get another list lookup object and map the rate code field. In the list lookup properties, we'll provide destination values for each source value. Next, we need to provide codes for location values in the data. Since the list of locations across the city is quite extensive, a file lookup will be used to retrieve destination values. Let's get the file lookup object from the toolbox. In the file lookup properties, let's first define the source file type as delimited and then provide the file path. In the lookup properties below, let's specify the input column for which destination values are anticipated. In this case, our input column is location ID. Once we have specified the file for the location, we needed to decode values for two fields in the data pickup location and drop-off location. To use the file lookup further for these two fields, we will use the data cleanse transformation to modify expression for the fields that will be mapped. Let's drag and drop the data cleanse object from the transformations and map the fields pickup location ID and drop-off location ID to it. Now, in the properties of the data cleanse object, let's give an expression through data modification option and run the given expression on all the mapped fields. Now when all the lookups have been applied, the next step is to organize this data before we write it into a database. We'll use the pass-through transformation for this purpose. Let's get the pass-through object from the transformations and map the relevant fields from the delimited source, list lookups, and data cleanse object. This data is now organized in a flat format to be written to a destination. We'll get the database destination object from the list of destinations given in the toolbox. Peter now has the data assembled and organized. He can further use this data to derive customer insights. He wants to know which trip type has been generating more revenue and the total distance covered by that type. Let's get the aggregate transformation object from the toolbox. Now, map the fields pickup location, total revenue, total distance, and trip type from the pass-through object. In the aggregate transformation properties, we'll specify the aggregate function for all the mapped fields. We'll count the pickup location, sum the total revenue and total distance, and group by the trip type. If we preview the output, we can see that trip type 1 has generated a higher revenue and also covered a larger distance. Let's write this data into a destination so that Peter can share it with other departments. We'll write this data to an Excel workbook destination. Peter now has an integrated data flow with data being written to a database and an aggregated data based on specific fields written to a separate destination to work with customer and write insights. Astera Centerprise provided Peter with the functionality to meet his data integration needs and enabled him to increase overall efficiency and improve services for customers based on those insights. Between cost pressures and customer experience, the digitization of transportation data can help increase data visibility and derive helpful insights for optimizing opportunities. Astera Centerprise can help eliminate the operational challenges that affect the capability of making data-driven decisions and improve productivity and processes for the transportation industry. Interested in using Astera Centerprise firsthand? Download a free trial today and see how you can leverage it to streamline your data integration processes.